an, we will make use of this formula where f of x equals k times lx minus x square. K is taken outside integral and we will use integration by parts to integrate this integrand. In this process, first function is written as it is. Second function sin pi n x by l is integrated, which will give negative cos pi n x by l divided by n pi by l. And next term will be negative, and first function's derivative is written here. We have derivative of L minus 2x, that is derivative of Lx minus x square with respect to x is L minus 2x, which is written here. This term is obtained by taking integral of this expression. We have integral of cos pi n x by L is sin pi n x by L divided by n pi by L, and this negative sign along with n pi by L must be multiplied along with the answer, and thus we have negative sin pi n x by L divided by n pi by L the whole square. Next term will be positive and we have to write derivative of L minus 2x with respect to x, which is negative 2, and this term is obtained by integrating this expression. We have integral sin pi n x by L equals negative cos pi n x by L divided by n pi by L. We have this negative sign and the negative sign which comes after integrating sin pi n x by L becomes positive here. Also n pi by L the whole square gets multiplied, thus we have the denominator becoming n pi by L the whole cube. Now we can bring the denominators n pi by L the whole square, n pi by L the whole cube as reciprocals multiplied to corresponding numerators. Thus we get an equals 2k by L multiplied to negative L by n pi into Lx minus x square into cos pi n x by L plus L square by n square pi square into L minus 2x multiplied to sin pi n x by L minus 2 times L cube by n cube pi cube multiplied to cos pi n x by L. Now we will apply upper and lower limits. When you give x equals L here, it becomes L square minus L square, which gives the answer as 0. When you give x equals 0 again, you get 0 minus 0, which is 0. Both application of upper and lower limit will make this first term 0. When you give upper limit x equals L here, this becomes sin n pi, which is 0. When you give lower limit x equals 0 here, again it becomes 0. Second term is also 0 when you give upper and lower limit. When you give x equals L to this term, it becomes negative 2 into L cube by n cube pi cube into minus 1 the whole raised to n, because when you give x equals L, this becomes cos n pi, which is minus 1 the whole raised to n. When you give x equals 0 to the last term, it becomes minus 2 into L cube by n cube pi cube cos 0, and cos 0 equals 1. This negative sign is due to the application of lower limit. Already the third term has a negative sign in front of it. Thus we have an obtained as 2k by L multiplied to 2L cube by n cube pi cube multiplied to 1 minus 1 the whole raised to n. This is because negative into negative becomes positive, and that is how we get a positive sign here. Thus the final expression obtained for an is 4kl square by n cube pi cube multiplied to 1 minus 1 the whole raised to n. Giving the expression of an and bn equals 0, in the Fourier series solution, we have general solution written as y of xt equals summation n range from 1 to infinity 4kl square by n cube pi cube multiplied to 1 minus 1 the whole raised to n sin pi n x by L cos pi n at by L.